Hello everyone, welcome to our channel Online Classroom. Today we are going to discuss the topic inverse of a matrix. So let's start the corresponding topic. Well, inverse of a matrix, this is a very important idea in case of matrix operation. Well, suppose we consider A by B, this kind of things, then obviously it can be written as A B inverse. But the question will arise, how we will calculate B inverse? That means inverse of a matrix. Look, the corresponding rule is, suppose if I consider any kind of matrix is A, then A inverse is nothing but 1 by, this is called determinant of A into adjoint of A. Now the question will arise, how we can compute determinant of A? Well, suppose A is a square matrix 2 by 2 and the corresponding determinant of A will be A, B, C, D, and in case of determinant we use this particular symbol. So obviously first we will focus on the principal diagonal. That means we will multiply those two number, that is your AD, and subtract those two number product, that means your BC. So ultimately we get determinant of A equal to AD minus BC. Okay, so if this determinant value is non-zero, then we can easily perform our A inverse value. Look, here I consider one of the matrix as A, B, C, D, and we want to find out the inverse of the corresponding matrix. Look, the corresponding determinant value is AD minus BC, and we also consider this particular value is non-zero. Now we will compute the adjoint of a matrix. But question is how? Well, first we focus on the element A. Okay, look, if I focus on the element A, then we just consider this row and this row discarded. So obviously we have D, and we will put that element D into the first place. This position is called plus position, so the corresponding member becomes D. Okay, now we move to the next case. Look, if I consider the corresponding element B, in this case we will discard this row and obviously this particular column. So we have the member C. Okay, now we will put that particular member in this position, but obviously the corresponding value will be negative. Here it is plus value, here it is negative value, so it will be minus C. Okay, next we will focus on the element C. If I consider the element C, obviously we have this particular column and this particular row is discarded, so we have only element B. Okay, so the corresponding minor of C will be placed here, and obviously its sign will be negative sign. That means plus, alternate sign minus. If I consider this is plus, alternate sign minus. Okay, now we move to the last point. Look, if I consider the element D, obviously this particular column and this particular row is discarded. So look, this particular column and this row is discarded, so we have the element A, and that element A will be placed directly in this position. So that is the total computation of inverse of a matrix in case of 2 by 2 square matrix. Okay, now we will move to the next portion, that is how we can evaluate the determinant of a 3 by 3 system. Look, suppose we have one of the matrix as A, B, C, D, E, F, G, H, I, and we want to find out the determinant value of the corresponding matrix A. Now how we will calculate it? Look, if I consider the point A, first we will discard this particular row and this particular column. So obviously the value will be A into this particular minor portion, so obviously A into this thing. Okay, that is the first part. In the second position, if I consider the point B, obviously this particular column and this particular row will be discarded. So we have DF, GI, this kind of things. So we have the determinant, this thing. So second position will be negative position, that's why it is minus b into this particular determinant. And in the third position, if I consider the point C, obviously this particular row and this particular column, this will be discarded. So we have C into DE GH, that means this particular position. So if you just break those determinant using this particular rule, obviously we have to break this one and this one, we get the final result as this one. So that is the total computation of determinant value in case of 3x3 system. Okay, now we will try to check inverse of a matrix in case of 3x3 system. Look, here we consider a matrix A, the corresponding matrix is given, and we want to find out the inverse of the corresponding matrix. Okay, look, this is your determinant. Using the previous rule, we can easily calculate. If I consider the 5 point, it will be 25 minus 1, that is the first element. Second one, obviously this is, if I consider 1, so obviously this particular column and this particular rule will be discarded, so it will be 5 minus 1, this value. Similarly, if I consider the point last one, that is your 1, so obviously this particular column and this particular row will be discarded. The value will be 1 into 1 minus 1 into 5, so it will be 1 into 1 minus 5. So if I proceed it further, then we get the final value as 112. You can easily check the corresponding calculation. Well, now we will focus on the adjoint portion. Okay, look, here the corresponding 3x3 system is there. That means first we have to focus on the adjoint portion of A. Okay, we have to create the total, minor as well as the cofactors of the corresponding matrix. Okay, look, if I consider the first point, that is your 5, so obviously we have the minor 5 1 1 5, so that is your corresponding plus position first value. Okay, in the second place, if I consider the particular point 1, look, this one, then the corresponding minor becomes obviously negative position and 1 1 1 5, so that is the minor. But whenever it is the corresponding minor is with the corresponding sign, it is called as a cofactor. Okay, so move to the next position. Look, in this particular case, obviously we consider the point 1 and the corresponding minor is 1 1 5 1, but the position is obviously alternate position, that is plus position, and this is the corresponding value. Okay, so that is the first part. Now we will move to the second part, that means second column. Say, look, I consider the corresponding element 1, so obviously minor becomes 1 1 1 5, like this. So this is the corresponding negative position of the minor, and obviously together it is called cofactor. Okay, now we move to the next point. Look, if I consider that particular position 5, the minor becomes 5 1 1 5. Okay, and the position is plus position, so this is the corresponding cofactor. Okay, next, if I move to the last point, that is your 1, we have the minor as 5 1 1 1. So look, this is the corresponding minor and the symbol is negative, so this is the total cofactor. Okay, now we move to the last column, that is your 1. Okay, if the corresponding point is 1, obviously the minor becomes 1 5 1 1, so this is the corresponding minor. And similarly, we can easily consider the next minor together with the symbol, and also the next minor together with the symbol. So that is the total matrix. And if I take one transpose of this corresponding matrix, this is your corresponding adjoint of A value. Okay, so just use your corresponding determinant rule, that is 25 minus 1. Next one will be obviously 5 minus 1. Next one will be 1 minus 5. Okay, and similarly we can easily calculate this column and also this column. Okay, so after evaluation we get the corresponding matrix as 24 minus 4 minus 4, that is your first row, minus 4 24 minus 4 second row, minus 4 minus 4 4, that is your third row. Okay, and if I take the transpose means obviously rows will be in place of column and columns will be in place of rows. So if I do it, then we get the final value of the corresponding matrix A is this one, that is A inverse value will be 1 by 112, that is your determinant value, and this particular adjoint value. Okay, so this is the total computation of inverse of a matrix in case of 3 by 3 system. So using this idea we can easily calculate any kind of computation in case of 3 by 3 system. Okay, so in the next portion we will focus on rank of a matrix, and we will also focus on the characters of homogeneity and others in the next video. Okay, so thanks for listening us.